Hey, welcome to the 5.2 notes. This is power functions, page 1. So we are going to make sure that we can identify the degrees of polynomial functions, find those real zeros, determine what this function is going to look like so we can graph. So that means using end behavior, intercepts, turning points, and domain and range, and then graph it in factored form by hand. So a polynomial function is this really intimidating looking thing. But really this is the mathematical way to say I have a whole bunch of powers of x multiplied by a whole bunch of different numbers. Okay, the coefficients are the a sub n minus 1, a sub n minus 2 down to a sub 2. Remember, these subscripts don't mean anything other than these are coefficients that go with a certain term. And all of our coefficients are real numbers. Are real numbers. Our exponents are non-negative whole numbers. So I'm not dealing with negative exponents. We are not dealing with rational exponents, which gives us radicals, so no fractional exponents. We can have 0 because x to the 0 equals 1. Right? And we have an x to the 0 whenever we have a constant term. So a constant term is going to be degree 0. We got 3. Sorry, negative 14. Anything that has no variable terms. Linear is going to be degree 1. So 3x minus 2, x plus 7, highest power on x is 1. Quadratic is degree 2. We just got out of the section where we were talking about quadratic equations and graphing quadratic equations. So these are our x squareds. We don't have to have every single value in between. It's just that the highest power can be only 2. The highest power can only be 2. Cubic, 3. So I got x to the 3rd. Minus 3x squared plus 3x minus 1. As long as that highest power is a 3, it's a cubic and a quartic. Highest power is 4. Please understand, I am just making these up as I go. There's no rhyme or reason other than that highest power. And so I do want to highlight that piece. It's a quartic, a 4th degree polynomial function because the highest power is 4. It is a quadratic 2nd degree polynomial function because the highest power on x is 2. The degree is going to tell us the shape of the graph. We're going to move over here. And this is a general shape. It's going to tell us how many potential zeros or solutions. Yeah. So let's review from the last section. If I want to graph this function, f of x equals x squared minus 2x minus 3. The first thing we're being asked for is the zeros. So I'm going to go ahead and see if I can factor this. Only way to get x squared is x and x, so I'm going to fill that in. Only way to get 3 is 3 and 1, so I'm going to fill that in. So I know my zeros are at x equal negative 1 and x equal 3. Which is directly related to my x-intercepts. I get negative 1, 0, and 3, 0. And I'm going to go ahead and just graph those in here. My y-intercept is what happens when x equals 0. I'm going to change colors just so I can graph it in a different color. When x equals 0, my x squared term goes away, my minus 2x term goes away. I just get negative 3. I know because my leading coefficient is 1. I got 1x squared that this is going to open up. So I am going to have a minimum. I am not going to have a maximum. But in order to find the minimum, I need the vertex. So I'm going to go ahead and use what we used last section. The h coordinate of our vertex is negative b over 2a. From my equation, there's my negative. B is negative 2. 2 times a is 1. If you need a refresher on this, please go back to the 1.1 notes. Pretty sure that's on page 3. Yeah. So my x-coordinate is 1. To find the y-coordinate that goes with that, and I'm using hk here because that's how we found the vertex last time, calling it hk. I'm going to plug in that x-coordinate for the vertex. 1 minus 2 is negative 1, minus 3 is negative 4. My vertex is the point 1, negative 4. So my minimum is negative 4. Remember when we talk about maximum and minimum, it's the output value of the function. It's only the y. It's not a point. Because I remember that parabolas are symmetric, it's going to look the same on both sides of the vertex. I have enough information here to sketch my parabola. My domain is all real numbers, always for a polynomial function. My range. The lowest this goes is negative 4. And I got arrows going up, so this is everything above negative 4. Because we can actually hit negative 4, that's our vertex. I'm using a square bracket. My range goes from negative 4 to infinity.